Hello everybody. Hope you can hear us. This is the webinar for the Inspire Helsinki 2019 Commuting 2.0 Data Challenge, and we are Tuure Laurinolli from Vaisala, and
my name is Roope Tervo, Finnish Meteorological Institute. Good afternoon, everyone.
And we are going to present to you the Inspire Helsinki 2019 Data Challenge about commuting. And in general, the Inspire Helsinki Data Challenges, there are 4 of them. You can see the details on the screen. The idea is that there's some data set, and the challenge team can take the data set and do something interesting with it, produce some kind of a submission, and depending on the challenge, the submissions can be different. The awards, and please check the details on the website. And this webinar is about the Commuting 2.0 challenge. So how can commuting be more comfortable, and how could we increase the amount of commuting that's done in an environmentally friendly way compared to taking your car and driving to work? So the important things for an environmentally friendly commute are, we think, the comfort and the speed of the commute. And considering we are both from a weather background, we are concentrating on the comfort part here. So what if it starts to rain, or will it start to rain during my bike ride to work? Or if I take the bus, will the final 200 meters from the bus stop be pouring rain? Or if I take the next bus, will it be dry? And could I save getting wet and taking a shower at work? Or do I have to take the umbrella with me? And there is also the safety aspect, especially in the winter time. If you're taking the bike to work, it's very nice to know if you can actually ride, or if there are 10 centimeters of snow somewhere. Where have the plows been? And can I take the usual route, or do I have to take do I have to adjust my route to the conditions? So we think we have some interesting data to help answer these questions, and we would hope for your help in producing the answers from this data. And the outcome we would like to see is some kind of an online demo or proof concept software that takes at least one aspect that was presented previously, the comfort or the speed, or the some other aspect in commuting, and uses this data we present to help answer help the commuter make travel more comfortable. And we are using a novel technical method called WFS3 to make this data accessible. So we would also very much like comments on the delivery method and the data encoding. And especially if you wanted to do something but weren't able to do it because of some technical constraint, we would very much like to know that. And we may even be able to fix things while the challenge is ongoing if you get back to us during the challenge. So the data we have from the FMI, we have forecast data and current weather information. And from Vaisala, we have certain mobile weather observation data available. And of course, you can also use other data, such as the OpenStreetMap for the background map. And the National Land Survey has elevation models. They also have WFS3 service available, but I think that's only for placings for now. And then, of course, for example, if we are concentrating on Helsinki, there's the HSL developer community who are very keen to provide HSL data for all kinds of purposes. For example, the bus schedules or problems with the bus traffic, or I think they also have the live location data for buses available. And to the teams during the challenge, we can offer a chance to present the work results in the Inspire Helsinki 2019 event. Also, there's free trip to the 2020 Inspire Conference for one person on the winning team. And there are some tools available for use during the challenge, like FMI and whatever else we have.
ArcGIS server.
So if you want to use proprietary tools, we have some available.
And you can also use open source tools, of course. By the way, this is my name is Ilkka and I'm from Spatial. I'm just hanging around with you guys during the webinar.
Right. Anyway, onwards to the data and the data formats.
Okay, I'm going to tell you about WFS3, the new data interface we are providing for this challenge. This is a new server and upcoming new server standard, interface standard, to provide this kind of information. And we have developed this server together with Vaisala, Finnish Meteorological Institute, and Spatial. And our goals here is to design a new, simple, web-friendly data model and test feasibility of this WFS3 standard for weather data. And we are very happy to hear all comments you may have about this data model and interface. Just a quick mention that everything we have developed here is open source and it's available here. I'm not going into details, but if you are interested in, you can find the code and some documentation from these links. WFS3, well, first of all, it's based on OpenAPI 2.0 and it's designed to be a web-friendly interface with JSON outputs and data-driven interface, I would say. And I'm going to next show you a demo about FMI installation, which has weather forecast for Europe and weather observations from Finland available. Okay. Just quick to get this larger. If you navigate to the server front page, which was mentioned on the slides, you can find this kind of result web page if you navigate there with your browser. One notable thing here is that our implementation used the content negotiation, so that if you navigate to the web server with your browser, you get HTML, but if you use, for example, Widget or whatever other tool, you get most probably JSON output. And for all the pages here, you can get HTML output, and you can get also raw JSON output if you put F equals JSON, and this is what you get then. Okay, what we have here, first of all, we have a link to the server itself. Then we have a service definition, which have also data schema and data definition included. And there's 3 formats available: JSON, YAML, and HTML. Now, if we go to HTML, we can get this fancy web page which has all the information about the service available. Then we have conformance declaration here, and most importantly, we have data available, information about data collections, feature collections available in this particular server instance. If we click that, we get list of collections. Here we can see Hirlam, which is Hirlam surface forecast data, weather forecast, and provided parameters are listed in the description. Then we have always the same data in two different data formats, where we have data for as individual points and then as a time series. And then these open data collections are for observations. And this is what we have available here. Oh, by the way, we have also some air quality data available as well. Then we can click to see on get actual data. We can click this link here, and we get some data here. Now, this is HTML output. We get some data from, or in this case, from somewhere in Sweden. And if we click the point, we get information that we have windcast 12 meters per second. And the output as a whole is JSON like this. You can of course filter this with several different filters. You can use bounding box, and for example, parameter names. If you are interested in, for example, temperature, you can type that observed property name is temperature, and you can add some place names. If we put, for example, place is Helsinki, and click, we get information from Helsinki. And you can, the place names are derived from geonames.org, and you can put any place name existing there. And then you get data from Helsinki. Okay, this is about FMI implementation. Then next we are going to Vaisala implementation.
Hello again. So we are running the same software, but it's connected to a different backend. This is connected to our cloud observation platform. And a bit contrary to what Roope said, the adaptation to our cloud platform is not open source. So you only have this interface available to the data. And you won't see the source code, I'm sorry. Anyway, we have the same service running as the front end here. So you get the server descriptions, you get the API descriptions, you get the conformance classes, and you get the data. And we only have a single collection of data available at this point. That's mobile data. These are mobile weather stations attached to vehicles moving around Finland. And we can hopefully see some observations from them in this tab here. So you can see that the measurements are quite frequent spatially and temporally. There's a car moving somewhere in central Finland. And the individual features are similar to what you get from FMI. We have the measurements, like for example, this is surface state of 3. The enumeration is probably documented in the API documentation. So what 3 means, if it's not, please complain, because it should be there. And then we have other information, like for example, the surface creep, which would be very, very useful in the winter, I'm sure, but perhaps in the summer not so much. We have snow thickness, water thickness. Water thickness might actually be very useful. 0.3 millimeters doesn't sound like much, but it sounds like a wet road. Ice layer thickness, no ice hopefully. Then we have the surface temperature, so it's quite warm, the road surface, even though it is wet. And we have some more. We have the dew and frost points, which are probably not useful unless you're a meteorologist. and we have the air temperature, which also seems to be pretty warm. So warm day at Äänekoski, it seems. Or perhaps the instrument is not optimally placed. In any case, this is what we have available at this point. Hopefully you can make some use out of it, and let's get back to the presentation. So also here we have the map of the coverage of the data that we have available at this point. More may be coming, but we are not sure yet. And please sign up for the challenge. You have until the 16th of August to do so, and then until the end of September, yes, to deliver the challenge. So sign up using this link, and if you have any questions, please ask using the question feature of this GoToWebinar.
Okay, if there are no more questions, just to let you know that this webinar has been recorded and will be provided in YouTube and also linked to the challenges website probably tomorrow. So if you have any colleagues who could not make it today, you can check the full recording on YouTube and on the challenges website. Okay, if there are no questions, thank you very much for joining the webinar today, and hope to see a lot of you participating in the data challenge.
Thank you very much.
Thank you.